Hey guys, Mr. C here. I'm going to do a couple collision problems with you to help illustrate elastic and inelastic collisions. So by the end of this video, you should be able to set up and solve an equation for an elastic collision, and you should be able to set up and solve an equation for an inelastic collision. You should also be able to recognize which situation is an elastic or an inelastic collision. All right, let's jump right into it. So here's our first problem. A 2-kilogram ball, initially moving at 3 meters per second to the right, I'm going to circle that, collides elastically with a 6-kilogram ball moving at 2 meters per second to the left. I'm going to circle that. After the collision, the 2-kilogram ball moves at 1.5 meters per second to the left, and they want us to calculate the velocity of the 6-kilogram ball. So what I find is most helpful for solving these problems is to draw a diagram. So you can see here I have a diagram before and after the collision. I've labeled the masses of both balls, and now I'm going to go ahead and label and draw their velocities. So the 2-kilogram ball has a velocity directed to the right of 3 meters per second, and the 6-kilogram ball has a velocity directed to the left at 2 meters per second. On the bottom, we see that after the collision, the 2-kilogram ball moves to the left with a velocity of 1.5 meters per second, and we need to calculate the velocity of the 6-kilogram ball, so we don't know the direction yet, so I'm just going to write v. We haven't figured out the direction yet. So one little notation we need to start with before we go anywhere is in terms of velocity and direction. So you'll recall that velocity is a vector quantity, meaning it has both magnitude and direction. So what I'm going to say is anything moving to the right means positive velocity. Okay, so I'm going to say anything moving to the right has a positive velocity, which means that anything moving to the left is going to have a negative velocity. So what that means is that 2 meters per second is actually going to be a negative 2 meters per second when we talk about it in terms of doing our momentum, and same thing for the momentum afterwards for the smaller ball. So to solve every momentum problem, we'll use our conservation momentum equation, PV4 collision equals the momentum after a collision. And to solve every problem, we solve for the piece of the momentum before, and then we set it equal to the piece of the momentum afterwards. So here's my P before. It equals the momentum of the small ball plus the momentum of the large ball. So momentum is mass times velocity. So for the first ball, it's 2 kilograms times 3 meters per second plus 6 kilograms times negative 2 meters per second. And again, it's negative because the larger ball is moving in the opposite direction to the smaller ball. So go ahead and solving. I'll let you guys go ahead and calculate that. You should get an answer of the momentum before is negative 6 kilogram meters per second. Now the balls, because it's an elastic collision, bounce off each other, and the small ball bounces off to the left at a velocity of 1.5 meters per second, and the large ball has a velocity v. So we know that because momentum has to be conserved, that P before, or that negative 6 kilogram meters per second, has to equal the momentum afterwards. So we're going to solve for the individual piece of the momentum afterwards. Well, let's do the little ball. So the momentum of the smaller ball is 2 kilograms times negative 1.5 meters per second, and the momentum of the larger ball is 6 kilograms times its velocity. So what you see here is this reduces to an algebra problem. We get negative 6 equals 2 times negative 1.5 is negative 3 plus 6v. Go ahead and solving for v. I'm going to add 3 to both sides, and I'm going to get v equals 0.5, negative 0.5 meters per second. And when I say negative, what that means is that ball must be moving to the left. All right, and there you have it. There's a simple elastic collision problem. All right. Now we're going to go ahead and do an inelastic collision. So go ahead and pause and write this down if you need it. I'm going to go ahead and get started. A 1,200 kilogram truck moving to the right at 25 meters per second rear ends an 800 kilogram car moving to the right at 13 meters per second. When the two cars collide, they lock bumpers and continue moving. So we want to find with what velocity do the two cars move after they hit and lock bumpers. So again, here's my picture drawn. We have the two cars driving along. The truck is moving at 25 meters per second, and my car is happily moving along at 13 meters per second. After the collision, the two cars lock bumpers. You can see they're pretty upset about it, and they move off at a velocity that we're going to try to solve for. So again, we're going to do our conservation momentum. So momentum before the collision equals momentum after the collision. And so I'm going to add up the individual pieces before and then set them up to the pieces afterwards. So let's go ahead and do our momentum before. So I'm going to do it right down here. Momentum before equals the momentum of the truck plus the momentum of the car. So for the momentum of the truck, it's 1,200 kilograms times 25 meters per second plus the momentum of the car. So 800 kilograms times 13 meters per second. I'll let you guys go ahead and calculate that. And when you're all said and done, you should get a momentum before of 40,400 kilogram meters per second. Now, I'm going to set that equal to the momentum afterwards because we know the 40,400 kilogram meters per second has to equal the momentum of afterwards. That's our law of conservation of momentum. So now we need to find a way to express the momentum of the cars after the collision. The first thing we need to do is figure out what the mass of the cars are. Well, if they lock bumpers, that means that the mass, when we consider the mass of all of them together, we need to add the mass of the truck to the mass of the car. So the mass of the two cars together is 1,200 kilograms plus 800 kilograms, or 2,000 kilograms. And again, it's moving off at a velocity v. So when we talk about our mass times velocity, we're going to go ahead and we're going to do a mass of 2,000 kilograms times a velocity v. Now to solve for v, we divide by 2,000, and so doing so we get v equals 40,400 divided by 2,000, which comes out to be 20.2 meters per second. And there you have it. We've solved for the velocity of the two cars after the collision. Namely, the velocity of the two cars after the collision is 20.2 meters per second, and it's to the right. All right, well, I hope this helped you guys out with elastic and inelastic collisions. Stay tuned for more.